For lesson number 6, we'll be talking about how we can represent ratios with equations, okay? Equations are new to us, and we're just going to look at this one specific type of equation today, all right? So what we need to talk about is the value of the ratio. It's this special number that represents the relationship between the two quantities, meaning between the two columns in our table, okay? It's often easier to see it from the table. And once we have it, we can write it into an equation. And equations are going to be super helpful for us, and we'll talk a lot more about them in the next couple of units. Okay, so check out our situation. We have hours worked turning into money earned. And we want to say, what is the process? How do we get between the hours worked and the money earned? Okay, first entry says 0, 0. I don't know for that one. That's not useful. They're both 0, right? But to get from 1 to 9, we could multiply. We'd have to do 1 times 9. And I just want to remind you there are several ways to write multiplication. Okay? And you can kind of choose which one you want. I'm going to use the dot because it's best for the topics that we have coming up. Okay, 3 to 27, that would be 3 times 9. 6 to 54 would be 6 times 9. And then 8 to 72 would be 8 times 9. So we see this thing here called the value of the ratio, and it's this number 9 that's really helping us. And what we can do is just fill out the rest of the table with it. So it must be 0 times 9 equals 0. Okay? And what we want to do is take this whole situation and turn it into an equation. And we're actually going to pull in some of our information from the coordinate planes unit. We're going to talk about x and y. Here's the easy thing. When you label your tables, x and y is always in order. The first column should be x, the second column should be y. So our x variable has to be the hours worked because that's the first column. And we will talk more about why those labels are those labels when we get into the next unit and we get a little bit more specific with some of these things, okay? And then y is the money earned. Just literally because the first column is always x, the second column is always y. It's just a standard. Okay, now how did we get from x, that first column, to the y column? Well, we did times 9, and then that gave us y. So x times 9 equals y. That's kind of an equation. Let's get rid of the word times. Now it would say x times 9 equals y, but if you want to be really fancy, you can write it in this method. You put the y equals first, and then you write the 9, and then the x right next to it. I told you there were these 3 ways to write multiplication. There is a fourth, and that is when you write them squished right next to each other. It has a fancy name. It's juxtaposition. Don't worry about it. But this is the fanciest, most acceptable way to write an equation, and this one is okay as well. It's not the way we would normally write it, but it means the exact same thing, so totally up to you. Okay, so let's take a look at our next table. A bike rider cycles 20 miles in 1 hour. So I see right away that I have hours and I have miles here. And it looks like I need to fill out one of these rows in my table so that I can try to figure out the process, like how we're changing from hours to miles. So it says 20 miles in 1 hour. So I'm going to look and see I have 1 hour right here. So that should go with 20 miles. And that's kind of our key. How do you get from 1 to 20? Well, you would do 1 times 20. So follow that same pattern. Now it's 2 times 20, which is 40. The next one would be 3 times 20, which is 60. 4 times 20, which is 80. And then whenever you have a 0 row, just do the same thing. 0 times 20 is 0. Why did we do times 20 for all of these? Well, because we had to follow the process of our original ratio, which was 1 hour, 20 miles. And to get between those, it's times 20. Okay? So now if we go to write our process down, we're going to take basically all of these example ones and make it general. So instead of 1 times 20, it's just whatever is in this hours column times 20. So hours times 20 gives us the miles column. So hours times 20 equals miles. Hopefully you can see that. And then to translate that into math, we just use our variables, a letter instead of a word. So we want a letter that's standing for hours. We have one right here. We're going to use H. And we know to write times, we can do a dot and then 20. So H times 20, I translated it to math, equals miles. And for miles, we can use M. And if you want to write it the fancy way, either way is fine, but the fancy way, you're going to flip this around. You're going to put M equals 20H. So always putting the number in the front, no symbol in between, and then the variable. If you write it either way, it's totally fine, okay? Number 2, Tamara saves $38.50 every month. So when it says every month, we have to realize that that means every 1 month. So in 1 month, the amount she saved was $38.50, okay? So that means from 1 to $38.50, it's the same thing. We're going to do 1 times $38.50. So even though it's a decimal, it's the same thing. So to get across, we're doing times $38.50. So 3 times $38.50, 5 times $38.50, 7 times $38.50. You see the pattern here? 9 times $38.50. And let me just calculate these really quick. So after your calculations, that's what you would have. Now let's describe the process. So in general, to get from the months to the total saved, we're taking the months and we're doing times $38.50, and then it's giving us the total saved. So months times $38.50 equals total saved. Now, luckily, we have some variables up at the top of our table. We have M and T. So we can say M times $38.50 equals T. M for months, T for total saved. Okay? If you want to write it the fancy way, flip it around. Put the T in the front. T equals, and then $38.50 M. So variable squished next to that number, that key number that's getting us across the table, the value of our ratio. Okay? So we can actually use this as ordered pairs as well. So I kind of mentioned that earlier. You can turn your ratio table just straight into an ordered pair. So for example, here in number 3, a recipe for oatmeal raisin cookies requires 2 eggs for every 1 dozen cookies. So that sounds like a ratio. It says for every. So 2 eggs, 1 dozen cookies. And we actually have our entire ratio table set up. We just have to write the process. So this one's kind of weird because if I'm trying to get from 2 down to 1, I can't multiply by a whole number. I have to multiply by a fraction. So how do you turn a 2 into a 1? It's actually the number 1/2. So if I do 2 times 1/2, that gives me 1. In case you don't believe me, I'll write it right here. 2 times 1/2. Remember, you can fill in the 1 underneath, multiply the tops, multiply the bottoms. That's just equal to 1. So now do all of these times 1/2, because if I want to get from a 4 down to a 2, I have to cut it in half. 6 times 1/2, half of 6 is 3, perfect. 8 times 1/2, half of 8 is 4, perfect. 10 times 1/2, half of 10, 5, perfect, it worked out. So now, this one's a little weird because it has a fraction in it, but just like with the decimal in the previous example, it works. And our new thing is to write our ordered pairs. So remember, we said the first column is X and the other column is going to be Y. So when you write your ordered pair, you write X, comma, Y. So easy as this. Here's my X, here's my Y. 2, comma, 1. Here's my X, here's my Y. 4, 2. X and Y. X and Y. X and Y. Okay? Now, before we plot it, because that's a new thing, let's just write the equation. Okay? So we're going to skip the step where we write it out in words. We're going to take eggs, which is E, and what do we do to the eggs to turn it into the cookies? Well, we do eggs times a half. And that equals the dozen cookies, C. Okay? Or if you want to be fancy, flip it around. C equals 1/2 E. Either one of those is fine. Now our last step is to plot it. So remember, this is 0, 0 right here. So if I want 2, 1, I have to go over 2, up 1. 4, 2 would be over 4, up 2. 6, 3 would be over 6, up 3. Over 8, up 4. Over 10, up 5. So that is our plotted ratio table. All right, now just one more example. A cell phone company charges Joey $45 per month. So again, whenever you see this like per something thing, it just means for one. So 1 month, $45. And I can clearly see our process. To get from 1 to 45, that's 1 times 45. Now, we don't have a list of months. I'm just going to count by ones. So I'm going to do 2, 3, 4, 5. And then fill it in. The process is to multiply the months by 45. Months by 45. Months multiplied by 45. So now that we've got those multiplications in, we can go ahead and do our next step, which is to fill out our ordered pairs. So remember, X, Y, always in that order. So we're going to do X, Y for our ordered pairs. 1, 45, 2, 90, 3, 135, 4, 180, and 5, 225. So we can go ahead and we can write our equation before we plot it. We're going to take the months, times it by 45, as you can see, and that equals the total, which is we're going to just call T. If you want to change that the other way, T equals 45M. Either way is fine. All right, now on our X, we're going to do 1 through 5. So 1, 2, 3, 4, 5. This is 0. But on our Y, we have to count by something else. So let's just count by 45s. So we can say, you know, this is 45, this is 90, 135, 180, 225. As long as you skip counting, this works out pretty easily. And then when you fill it out, it's just going to be perfectly straight across because that's how we set it up. Okay? And if you want, you can even be one step fancier and you can connect these with a line. And you can see that that line actually has the equation T equals 45M. And that's it. We're going to talk more about the coordinate planes in our next lesson.